Okay, next we're going to talk about set operations. Now, set operations are operations that we can perform on sets, similar to how we add, subtract, multiply, and divide. This is kind of the equivalent thing, but in terms of sets. So first, some definitions and what all of these different things will mean. So first, a universal set is the set of all of the different elements that we are interested in. So it doesn't mean every single thing in the universe. For example, I might just be interested in all of the students taking Math 110. That would be my universal set. I might simply be interested in the set of movies that I saw in 2019. I don't have to think of everything under the sun. I can narrow it down to a smaller group. So that's a universal set. Now, what can we do with different sets? One is we can form a union of sets that contains all of the elements in one set or another set, or potentially both sets. There could be some overlap there. The union is denoted the following way. This would be like set A union with set B, so it looks like a U but no little tail. And so what this would mean is that some object X is an element of the union if X is an element of both set A, or X is an element of set B. Okay, so it belongs to one or the other. Again, it could perhaps belong to both, and that is an important note to make. In mathematics, or is inclusive. It could mean one or the other or both. The intersection is our next set operation. That is the elements that are in both sets, and it is denoted in the following manner. So that's read A intersect B. So some element X would be in the intersection if X is an element of A and if it's also an element of B. So in other words, something that is in common between both set A and set B. The next one is the complement of a set is everything not in the set. It is denoted A with an exponent of a C for a complement, or occasionally you'll see the notation A prime. I will choose to use the A with the C superscript as much as possible. However, you will occasionally see that A prime show up. So please remember that those are interchangeable. So if X is an element of A complement, that means it's not an element of set A. What's not in there, kind of the opposite of, if you will. And then the last operation we're going to talk about is the difference of sets. And the difference is denoted exactly like a difference is in arithmetic. It's a subtraction symbol, A minus B. It's the set of elements in set A that are still left over after you take out any elements that are in common with set B. So it's an A and A alone. So what that would mean is some element is in the difference of A and B if X is indeed an element of A and it doesn't happen to also be in set B. So let's take a peek at what that might look like in kind of a word example here. So we have all of the students at a local high school, and they have a cross-country team and a track team. We're going to let all of the athletes on the cross-country team be set C and all of the athletes on the track team be set T. So for the high school, describe what is the universal set, or what is the large group, in this case, of students that we are looking at. Well, it's not just about the people on the cross-country or the track teams. The universal set would be all students at the high school. That's kind of our framework that we're working with, all the students in the high school. So who would be in the set C union T? Now remember, a union means or. So these are all students on the cross-country team. I'm going to use XC for cross-country team. Or on the track team. Again, or both. Okay, that would be in the union. So you're going to take everybody who runs cross country, everybody who runs track, and kind of throw them in one big pile, if you will. And if they run both, they're still in the pile. That's a union. Okay. So who would be in the set C intersect T? Well, the intersection is what they have in common. So where do the cross country and the track team have things in common? Well, those are the athletes or the students who are on both teams. Okay, so these are the students on both the cross country and the track teams. All right, on to the next page. There's two more questions that follow this one up. So for the high school described, who would be in the set C complement? So C being our cross-country athletes, and then the complement means they're not cross-country athletes. Now remember, that does not mean that they have to run track. There are a whole bunch of students in that high school that might not run cross-country or track. It doesn't mean every kid in the high school has to do both. So these are all students who are not on the cross-country team. And that's probably a whole lot of people if you think about it, okay? It includes not only people who just run track, but everybody else, the people who don't play any sports at all, the people who are into art, the people who are running track or playing basketball or whatever, but they don't have to be in sports at all. And then finally, who would be in the set T takeaway or T minus C? So the set T is all of the track team, and then we're going to remove the people from the track team who run cross country. So think of all those athletes standing there, and I say, okay, all you track people, now if you run cross country, go stand on the other side of the room. Who would be left right in front of me? Well, the athletes who are only on the track team and not on the cross country team.